Hi guys, in this lecture we will try to visualize RDD in Spark. Before that, I want to cover some like minimal topic. What is the full form of DAG? I already told you this is directed acyclic graph. And a DAG is generated when we compute Spark statement. When we are computing Spark statement means Spark transformation, Spark code. And execution happens, this line you should remember. And execution happens when action is encountered. Before that, only entries are made into DAG. DAG means directory acyclic graph. The entries to the DAG will happen until we are not hitting our action operation. So this is the test statement I noted down here. Execution happens when action is encountered. Before that, only entries are made into DAG. And DAG look like this. Load, map, and other operation they're going to be reduced by q will be that is also reduced by, that is also one transformation. Then this is one DAG. It will look like this, and I will show you. Okay, I will show you practically what I will show you this DAG when we will try to do practical. Okay, now we will start visualizing our RDD. So let me draw some diagram. Okay, suppose we have four node cluster. Okay, we have only 4 node cluster. Before that, let me reduce my, we have only 4 node, shit, we have only 4 node cluster. Okay, and this is my driver machine. This is my worker node. Worker node 1, worker node 2, worker node. Let's think we have 3 node cluster, not 4 node. Okay, I don't have space here, so 3 node cluster. Okay, in HDFS, if you imagine, if we have 500 MB data in our HDFS, in HDFS we have 500 data. So how many blocks it will occupy in HDFS as per default block size? So as per default, the default block size is 128 MB. So if we divided 500 by 128, there will be 4 block. There will be 4 block. Okay. So some block 1 will be here. Let's think block 2 will be here, and that last node we have block 3 and block 4. So one node will hold 2 block, and that's how the HDFS works. So this part is HDFS. Okay, this is part is HDFS. So when you are storing some data in HDFS, they will try to divide that 500 data MB data in HDFS like this. So it will split data into block 1, block 2, block 3, block 4, and this is HDFS. Now what will happen in Spark? So in Spark, block loaded into memory as a partition. What I am trying to say, this block will load into our RAM as a partition 1, as a partition. So what will happen? This block 1 will be partition. Let me read. So this will be partition 1, partition 2, partition 3, 4. So this block will load into our memory as a partition 1. This block will load in our memory RAM partition 2. This block 3, 4 will load in our RAM as a partition 3, 4. This will be in RAM. Okay. And that's actually happen in our Spark. So when you are saying Spark, so this block will load in our RAM as a partition and it will form our RDD. So we can say that this partition is RDD, or base RDD. You can say this partition, whole, everything, partition 1, partition 2, partition 3, partition 3, 4. So this thing called as RDD in Spark. So whole thing will call as a Spark. That's why we called, if you remember, that's why we called Spark as a resilient distributed data set, because it is distributed among this 3 worker node, among this multiple worker node, it will, the data will be distributed. That's why that data is distributed. We are saying this whole thing as a one RDD. So when we are saying this RDD 1 equal to sc dot text file, it means the at inner level the data will split into partition in multiple machine, and that whole partition, this partition 1, partition 2, partition 3, 4, we called as RDD1 here. So it is a distributed data set. So when you are saying RDD1 means we are pointing the data what is present in RDD this worker node 1, what is present in RDD worker node 2, what is present is in RDD worker node 3. So everything combining is a RDD, and that is in RAM. So that's how we can visualize this. This is our block. It will load into our memory RAM as a partition, and we are saying this partition as a RDD in Spark or Spark. So blocks are distributed across the disk, and RDD also distributed across memory. So there are two things. I hope you able to understand what I am trying to convey. So these blocks are also I'll give this note, attach these notes below this video, so you can check the description of this video. You will find this note. Okay, so one note point to be noted: blocks are distributed across disk and RDD RDD is distributed also distributed across memory, so remember this. Okay, and remember this diagram. So in HDFS, in the disks we have a block 1, block 2, block 3. That's how HDFS work. It will try to split the data. In the SpicePark, this block will load in our RAM as a partition 1, partition 2, partition 3, 4, and this whole thing called as RDT in our Spark or SpicePark. We already know that if we partition, if we load our data 500 MB data and default block size is 128 MB in our HDFS, so there will be 4 blocks, and there will be 4 blocks, 500 by 128, 4 blocks, 4 blocks, there will be 4 blocks in HDFS. So I want to say one thing, the number of partition is equal to number of block. That is not a Spark, like I know in HDFS also same. Like I just rewriting it. Remember this one, number of partition equal to number of blocks. And we already know that RDD are resilient. What the resilient means? The RDD is resilient because before that I want to say RDD is in memory. RDD is in memory. I repeating again, RDD in memory because everything in RAM. Everything is in RAM. RDD will store the data, the RAM. So RDD will have 4 partition. So the data will be brought from HDFS which are in memory. So it will load the data from HDFS and it will store in the memory. In memory means RAM. And it is distributed among the dataset, among the 4 machine, among the 3 worker node. That's why it is distributed dataset. RDD is distributed on RDD distributed among this worker node in form of partition. And resilient is a one property I already explained you. And what is the meaning of resilient? If I want to exactly the definition, if resilient means fault tolerance. And what is the, and if I want to say more layman way, the the ability ability to quickly recover from failures. This is our definition of resilient. Which means fault tolerance, the ability to recover from failures. I already explained like one failure scenario, and the I already explained this failed scenario. Let me let me repeat that this scenario again. So ability to recreate the lost RDD during execution cycle. So if the one RDD one, I am repeating some concept here because I want to after this lecture you should be in good condition and you should understand everything. That's why I'm repeating again and again. RDD 3. So if this RDD 2 is lost, so there should be that Spark is ability to recreate this RDD 2 from our DAC, from our execution cycle means DAC. RDD will recreate this RDD 2. This Spark will recreate RDD 2 using this DAC. If this RDD 2 is lost. And also this lineage graph also we called one lineage graph. I mean DAG also called as a lineage graph. So what this DAG will do? So DAG will keep a track of transformation to be executed after one action has been called. So I am reading some definition. Let me explain. So this thing you will DAG also called as a lineage graph. Lineage graph means DAG. Okay. So DAG, I mean lineage graph provides fault tolerance. I am noting down this point so that I can share with you. Fault tolerance through lineage graph. Okay. And this lineage graph will keep track of lineage, I mean DAG keeps track of transformation to be executed after. So DAG keeps track of those transformation and that to be executed, those transformation to be executed after an action has been called. Until that action is not called, the DAG will keep track of all those transformation. And RDD, the lineage graph also help to recompute any missing or damaged RDD because of node failures. So we are storing some RDD here and here, worker node here, worker node 1, worker node 2, 1, worker node 3. So we are storing some RDD 1 here, let's think, or RDD 2 here. If this node is gone, so so in that scenario, if this node is down, in that scenario, this RDD 2 will be created by Spark engine using this DAG. So DAG will help you recompute this RDD 2 again if this node is gone. So when an execution is entered, a path will be created which defines the order of the execution operation. This inform is remembered as a lineage graph. So they are so DAG will mention some order. Okay, it will not like it will put those operations as a random order. It will mention some order. In that order, operation will execute. So in this lecture, that's it. I think I already covered everything. And next video we'll try to cover practically. Before that, I want to like repeat once again on concept immutability. I already told you about this, but I will try to recover it to give you more understanding. So RDD are immutable, like we cannot be changed once it's created. Okay, RDD cannot be changed once it's created. Immutability or lineage or allows regenerate the RDD. That's the one thing. Okay, immutability means we cannot change the data of our RDD, and this immutability and lineage graph. Lineage graph means DAG. Even DAG allows you allows allows you to regenerate allows to regenerate the RDD during node failure. If some node is gone, then these two property will help you, immutability and lineage graph. because if we have a only lineage graph, that will not help. We need immutability. I already explained why do you need, because if we change data, if we change like value of one variable again and again, then we can recompute that value of that variable, because we are already changed that value of that variable multiple times. We cannot regenerate it. That's why it should be immutable. And I already told you why transformation are lazy. I already told you we called as. Also, I can give you an example, but I think it's already clear why transformation are lazy. Let me also give one example. Okay, try to explain. I will try to explain that concept again so that you can understand easily. If you understand it, if you already know why Spark is lazy, why transformation is lazy, you can skip this part. But for all noob guys, I'll try to explain once again. Let's think we have a file, we have a 2 GB. Before that, I will try to why transformation transformation are are lazy. Okay, okay. So I will cover this part in next video because it is already 21 minutes. So I will try this. I will try to cover. I will cover this part in a separate video. Okay. Bye. Thanks for watching.